Hi everyone, my name is Jerry Way, and I worked in collaboration with Saeed Hassanpour at Dartmouth College on our project, Learn Like a Pathologist, Curriculum Learning by Annotator Agreement for Histopathology Image Classification. So the ultimate question that our paper aims to explore is, are there tasks with domain-specific properties that are naturally appropriate for curriculum learning? In our work, we focus on curriculum learning, which is an elegant idea inspired by human learning that proposes that neural networks should be trained on examples in a specified order based on difficulty, typically easy to hard, and this contrasts with the random ordering of examples that is currently common in practice. At the top of this figure is the common random ordering in a single stage, and below that is the same data but split into a curriculum learning schematic. And you'll see that this curriculum learning schematic first trains on the easiest images and gradually adds in more difficult images along the way. But when trying to apply curriculum learning, we see two central challenges that arise. First, curriculum learning requires that a range of easy and hard examples actually exists. Although one could argue that this is true for any given dataset for at least some definition of easy and hard, tasks with a smaller range of example difficulty are less conducive to effective curriculum learning because the added value of curriculum learning comes from utilizing the varying degrees of difficulty in a task. Second, once we know that a range of easy and hard examples exists, we then need to find a way to categorize examples as easy or hard. Though sometimes effective, prior methods of categorizing difficulty can be hard to implement, and it's often unclear whether an approach that works on one dataset will work on another dataset. Indeed, scoring images by difficulty is the core problem addressed in many curriculum learning papers. Given these two challenges, we contend that histopathology image classification is an important task that naturally addresses the challenges above based on the following observations. First, we believe that a range of example difficulty inherently exists in many histopathology image classification tasks. This is because pathological disease develops over time, and so there must be a progression from normal tissue to diseased tissue. Since diseases are classified into discrete classes, there must be some points in this progression that lie on the margins of two classes and are therefore hard to diagnose. Second, histopathology image classification tasks have a natural proxy for example difficulty. Namely, this is image-level annotator agreement. As medical image datasets are often annotated by several trained clinicians, we can utilize the extent of agreement for each image as a proxy for the difficulty of that image. By definition, images with high agreement are easy to classify, as everyone agrees on them, and images with lower agreement are harder to classify. If these human notions of difficulty translate to a helpful curriculum for training neural networks, then many tasks with annotator agreement data already contain a curriculum that can be used to improve model performance. Our paper focuses on applying curriculum learning to the task of colorectal polyp classification, a challenging and clinically important task in pathology. Specifically, we focus on the binary distinction between hyperplastic polyps, HPs, and sessile serrated adenomas, SSAs. As you'll see in the table, our dataset consists of 3,152 images, representing diagnostically relevant areas of interest for HPs or SSAs. Each of the images was independently labeled as HP or SSA by 7 practicing board-certified gastrointestinal pathologists at our tertiary medical institution. For our testing set, we used the majority vote of labels as the gold standard label. We propose a curriculum learning framework that leverages annotator agreement to rank images by difficulty. For our dataset, which was labeled by 7 annotators, we partition our images into 4 discrete levels of difficulty: very easy, easy, hard, and very hard. And we use these levels to train our network in 4 stages that include progressively harder images. In the figure, you'll see an overview schematic of our setup. We compare our proposed model to multiple baselines, including a standard single-stage baseline and multiple modified curriculum frameworks. We find that our proposed curriculum learning method, which uses annotator agreement as a proxy for difficulty, indeed outperforms our baselines by more than 4.5%. So the main takeaway from our paper is that yes, there are certain tasks, such as histopathology image classification, that are naturally suitable for curriculum learning. We hope that our results provide inspiration for researchers to think more creatively and rigorously when choosing contexts for applying curriculum learning. Thank you all for listening to our talk.